A further application of combinations and permutations could be to probability. So we're going to take a look at a few of those types of problems. So let's say for some reason we have a box that contains 5 red and 7 green marbles. We are to randomly select 4 from the box. So 4 things that we want to try to compute. How many different ways are there to select the marbles? The probability that we pick 3 green, 1 red. Probability of at most 2 red. Probability of at least 3 green. Letter A is pretty easy. There are a total of 12 marbles, 5 plus 7, and we're to pick 4 of those. So for letter A, we're going to say 12 combination 4. And again, this is a combination because the marbles are indistinguishable among the groups. So we didn't say marble 1, 2, 3, 4, 5 for red. We just know that there's some red and some green. We're going to shove this into our calculator. And again, if you could verify this, I end up with 495. Now this is important because this is the total number of ways that we can select. And this is actually going to be our denominator, so long as the number of marbles that we're selecting does not change in total. Okay, so this is going to be the total number of ways to select. So now that we know this, letter B is probably pretty easy. What's the probability that we pick 3 green and 1 red? Well, we know that for 3 green, there are 7 of the greens total, and we want 3. We know that there are 5 red marbles, we want 1. And then we're going to divide that because it asks for the probability. So we're going to divide that by 12, 4. We're going to compute each of these. 7, 3 is 35. 5, 1 is simply 5. And then 12, 4 we already got in the previous problem is 1295. All right. So if we wanted to compute this, a couple ways we could do this. We could just do this as a fraction. And you can certainly leave it as a fraction. That doesn't bother me. So that would be 175 divided by 495. Another way is we could approximate that, and we can get a decimal. And I got 0.354. But most of us in probability, we probably want a percentage. So 35.4%. So it's not terribly likely, but it's certainly likely. A third example of probability. And I'm going to cut these. Paste it down here just for convenience. All right, and again, C and D. Now, what is the probability that we will select at most 2 red? All right, so at most means that we start at 0 and then we go up to that total number. Okay, so at most 2 red means we could have 0 red, or we could have 1 red, or we could have 2 red. Implicitly, that means that if we're selecting, okay, and remember we're picking a total of 4 marbles, that means we would have to have 4 green, 3 green, and 2 green. Right? So don't forget, every time you're doing these, just because you're only selecting one of the colors that doesn't, it's given, that doesn't necessarily mean that we can forget about the other one. Okay, so recall that there are going to be a total, I believe there are 5 reds. I'll just go back up to verify. So there's 5 red marbles, of which we want 0. There are 7 green marbles, of which we want 4. 5, 1, 7, 3, and then finally 5, 2, 7, 2. All right. Now we're going to go through, and don't forget we have to add these. Now I'm going to compute each of the different combinations. 5, 0 is 1. 7, 4, I don't think we've done that yet. But 7, 4 is 35. 5, 1 is 5. 7-3 is 35 also. We got that earlier. 5-2 should be 10, and then 7-2 should be 21. But I'm going to compute those just to make sure I'm not making any errors by accident. So I got 10 and 21 respectively. All right, so if we add those up, 35 plus 105, or 175, plus 210. I believe that works out to be 420. I'm just checking one more time just to verify. So I get 420. Now that's the total number of ways, but that is not the probability. Remember earlier in the problem, this is just the number of ways that we can select at most one red if we're picking 4 total. Don't forget that the total number of ways to pick is 495. So this is our probability, 420 out of 495. If we were to approximate that, that would be 0.848 or 84.8%. So it's actually very likely that we are going to pick at most 2 red marbles. So in other words, 0, 1, or 2. A final example is the at least problem. And so what's the probability that we are going to pick at least 3 green marbles? So, just like we did with the other problems, first thing we're going to do is we're going to select the different scenarios that could occur from this. So different scenarios. So at least 3 greens means that we would have at minimum 3 green or 4 green. Now we can't forget that we're picking 4 in total, so we're not going to go above 4. So this is basically the only 2 choices we have. Don't forget, implicitly, that means there's going to be 1 red or 0 red. All right, so if we select, we're going to end up with 3 green. Now get 3 green means we have 1 red, so that's 5-1, and then 7-3 for the greens. And then also, we're going to have 5-0, 7-4. Right, so let me compute those. We know 5-1 is 5. We know 7-3, I think that was 35. We can look up here. And 7-3 is indeed 35, as is 7-4. Remember, 5-0 was 1. Right, so basically, that just turns into 6 times 35. That's 210. Now that's the total number of ways, but that's not the probability. So for our probability, we're going to take 210, we're going to divide it by 495, which is still the total number of ways to pick. I end up with 0.424, or 42.4%. All right, so we can utilize our combinations and extend that into probability. All right, and this is used quite frequently when we start talking about statistics and data science and data analysis. So this is just a brief overview of those sorts of types of problems.